I want to start the question of what causes what. So it's actually a much bigger question than it seems like. This whole point about causality, and especially in the West, we have a very specific idea of causality. I would say that's what we call linear causality. So baseball A comes along, hits baseball B moves off. Okay, so cause, effect. So that's, I think most people in the West seem, pretty much to go along with that. We're always looking for what causes this, what causes that. But it's not always necessarily quite that simple. So, for instance, suppose there's something suppose there's some chemical in the ground that weakens the bushes in my garden, and then these caterpillars build a little tent on my bushes. I'm using an example that actually is there right now. It's probably not caused by a chemical, but I'm using these caterpillars there. And every time those caterpillars take over my bushes, I get really sick. Clearly, if I'm looking for a cause, I'm going to see a correlation between the caterpillars on the bush and me getting really sick. But actually, the caterpillars have nothing to do with me getting sick in the sense of causing it. Because I'm getting sick because the same chemical that has weakened my bushes is also making me sick. So that is a third cause. When I say a third cause, I mean it's a cause that's causing both of these things, right? So it looks like the caterpillars are causing me to get sick, but actually this chemical is causing the caterpillars and it's causing me to get sick. So correlation doesn't necessarily mean causality. So that's a situation where the cause is, if you did a reasonable study, sooner or later you'd find the cause. You'd find it was correlated with both things. Sometimes it's not quite that simple, right? So think about when you're playing a video game. When you're playing some sort of computer game, so you've got this guy here, shoots that guy there dies. So clearly, cause, he shoots, clearly, effect, he dies. But everybody knows that wasn't caused by the guy shooting that other guy. That was caused by whoever designed the game. And you could, of course, in that case, you could still follow the hitting of the keys, the moving of the electrons through all the computer circuitry and so on. And you could actually follow a chain of causation so that you see the picture set up. But you know that the picture is being orchestrated by something behind it. So that's another case of a third-party cause. It's not quite within the same system, though. It is within the same system in the sense of following the physical laws, all right? But I want to read you a story. I might have read it before. It wouldn't surprise me at all. So let me just read this. It's very short. Doesn't matter if I've read it before. So this is a story of the rainmaker. A rainmaker was called to a region experiencing drought. He arrived and immediately went into the hut provided for him, only to emerge several days later as it began to rain. When he was asked how he had made the rain, he replied that he had not caused the rain to fall. Rather, when he arrived in the village, he discovered everything to be in disharmony. He therefore retired to his hut in order to bring himself back into balance. Once balance had been restored, then nature returned to harmony and the rain fell as it naturally should. Okay, so here we have actually a very different story about causality. He says he didn't cause it, but he allowed the nature take its normal course. So that means that in some way nature's normal course was being upset by the disharmony amongst people. So this was a Native American story, and we're going to look into the idea of causality from several different perspectives in the next 2 or 3 videos. So let me just have a look at what science says. Science, let's go with physics. Okay, science is a big thing. It's not just one sort of uniform, there's not just one uniform thinking behind science. We have to distinguish between Newtonian science and 20th century science and so on. But anyway, so from the perspective of science, what causes the universe? And I guess, I mean, it's not quite, there's many different people trying to find out, what causes the universe, but many different models. And most people say, well, I'm not even going to deal with that because it's not physics, it's metaphysics. But really, I guess a sort of popular view is the idea that there was just a sudden quantum blip in the void. What does that mean? It means suddenly out of nothing, out of nowhere, no space, no time, no matter, no energy, no nothing, suddenly there was a big bang and everything came into existence. So where does causality fit with that, right? So, I mean, religious people say, well, God caused the Big Bang, or something along those lines. I don't know that clarifies much for the scientists, but from the scientific point of view, or from the point of view of the people who came up with that idea, the Big Bang was caused by a quantum blip. How do you justify a quantum blip in nothing? So the way you justify it is, if you look at the laws of the quantum physics in the universe, you find that things happen at random. A quantum blip is okay, according to quantum physics. So there's a certain probability of pretty much anything happening, even so-called impossible things. So that's how the universe came into being. The problem with this is that you have to assume that the laws of quantum physics are true. How could you have true laws, or even any laws, if you don't even have anything at all, right? So it's not really an explanation. It sort of says, it relies on the existence of the laws of quantum physics. And again, I'm actually speaking a little bit from within the perspective of linear causality, because you could certainly argue, well, there was no time before that, so can we really argue what's true before and after and so on? Okay, so it gets a little complicated. But let me just talk a bit about, I just want to establish how people thought of causality sort of traditionally. And let me go back to Aristotle and Plato and the ancient Greek folks. So Aristotle's idea was that there were several things that cause something to come into being. So there were like both material causes and non-material causes. If I want to paint a picture, right, let's say I want to paint that picture, then the material cause would be like the paper and the paint and so on. And then he called that the material cause, what something is made of. And then the efficient cause is the tool, the paintbrush and so on that you use to make it. Okay, so those are sort of essential, right? Can't get around. You couldn't create a picture without those things. But he also said, no, there's two other causes, right? So the formal cause is that moth that was in my mind. So the picture of the moth, right? I had to have a plan or a design before I paint a picture. So that is my formal cause. It's what's going to give the form to the thing that I create. But there's also one more cause, which is the final cause. And that is my purpose for creating it in the first place. Okay? So when somebody creates something, they do it for a reason. They want to express themselves, or they want to win a contest, or right, there's some reason for creating something, and that is your final cause. So Aristotle's ideas were that a plant, for instance, well, you have the obvious material causes for the plant, but there's also what he called a soul within each plant. Okay, and that soul was the origin of your formal and your final causes. And then ultimately the cause of the whole universe, the final cause of the whole universe, is God from Aristotle's perspective. So God's desire to create a universe. Okay, so I think that sort of includes all the different ways of looking at it. So then when you ask what is sort of, I guess, Newtonian science, what has that done? Which is still pretty much how we think, in many ways, how we do science now. So that has taken, I guess, it's taken the non-material side of things, the formal cause and the final cause, and put them all under the mathematical laws. So the mathematical laws are, in a sense, what causes things. Now, if you think about it, that really doesn't cover everything, right? Okay, so I can write an equation, and that's got all these, got the world around me. So why don't these molecules obey this equation if I write an equation, right? How do I get this equation to get these molecules to do something? So, in other words, you can have mathematical truth, but how do you make that mathematical truth shape everything? So the idea is that, we found mathematical truth by looking at the patterns that things follow, like the patterns of the orbits of the planets and so on. So reality is very ordered and structured, and you can certainly find a mathematical description of it. But I would say that the laws are more a mathematical description than a cause of what's happening. So I think that still leaves us sort of looking for a cause. Because basically, essentially what you have is just a whole bunch of sort of inanimate, blind, sort of unconscious material particles. So Aristotle's thinking of the soul in everything was 2,000 years ago. Science does not accept anymore, anyway, mostly. Science does not really accept that there's a soul in a plant. And even Plato didn't look at it like that. To Plato, he put his soul, so to speak, out there in a whole other dimension, a whole other place, a whole other reality where you have these perfect forms of things, and then the created world is just full of imperfect copies of these perfect forms. So even the ancient Greeks couldn't agree. But it's a big, big topic, and I think the story of the Rainmaker is something we can't just dismiss, right? We have to start asking, what is the role of that sort of thinking? Can we somehow, look at physics from a different perspective? So I'll talk more about that in future videos.